Okay, well, in addition to alkanes, there are many other families of organic compounds. We're only going to look at two other families of organic compounds. So alkanes were hydrocarbons, all single bonds. Alkenes are hydrocarbons also, so only carbon and hydrogen, but they contain always at least one carbon-to-carbon double bond. And so if this is ethane, a two-carbon molecule with all single bonds, then ethene is a two-carbon molecule, but there's a double bond between the two carbon atoms. And you can see that we went from C2H6 and now we're C2H4. So the general formula has changed. The alkane general formula was CnH2n plus 2. The alkene is just CnH2n. So there's always twice as many H's as there are carbons when we have an alkene. Otherwise, the naming system is pretty much the same. One carbon, well, there is no one carbon alkene because you can't have a double bond between carbons if there's only one carbon. So there is no such thing as methene. But there is ethene, and the next one would be called propene. Now here we get to but2ene. Now we're getting numbers. Well, if we can remember back to what the numbers told us in our names, the numbers tell you where the double bond is. Like they tell you where the side branches are. So numbers tell you about location. This molecule is 4 atoms long, 1, 2, 3, 4. No matter which way I number it, I can see that the double bond is in between the second and the third carbon. So the idea is we always kind of use the lower number when we have an option. So we say but, that tells me it's 4 carbon atoms long, so 4 carbons. The ene, I know that there's a C to C double bond, and the 2 tells me where that is. So I would, if I was drawing it and I saw this name, I would say, okay, there's 4 carbons in a row, and then I need to stick a double bond after the second carbon. And then I would fill the rest in with H's. Now notice that on the middle carbons, because they have a double bond, and then they have a carbon on either side, 3 of the bonds for those carbon atoms are already taken up. And so there's only one H needed here and one H needed there, because these guys already had 3 of their bonds taken care of. So carbon always forms 4 bonds. So that's why there's less hydrogen in alkenes than in alkanes, because the double bond is taking up one of the bonds for carbon atoms, so we don't get as many. So ethene is a C to C, and then we usually end up drawing it like this. Propene, so 3 carbons in a row, and then you can pick whether or not you write it on the left or right. Doesn't really make a difference. I'll just put the double bond here, and then so this first carbon already has 2 bonds, so that means 2 more hydrogens. The middle carbon already has 3 bonds, so just 1 hydrogen, and the last carbon only has 1 bond right now, so then 3 hydrogens. So therefore we get C2H4, and then we get C3H6, we're getting C4H8, and so on. Okay, I'm going to skip ahead. You get the idea. The last group that we're going to look at are the alcohols. This group was used in the specific energy lab, so they'll sound familiar. So alcohol ends in -all, and that's how these names will end. That's how you'll know it's an alcohol molecule. So we've got, if we go down to the names, when we have a 1 carbon alcohol, it's going to be called methanol. So that anol or all part tells us it's an alcohol. 2 carbons, ethanol. 3 carbons, propanol. 4 carbons, butanol, and so on. But just like with the other things, what it means to be an alcohol is to have an O to H group. So an oxygen atom and a hydrogen atom bonded together, sticking off of the carbon chain. That OH group can be in multiple different locations on the molecule. So how will we say where it is? Well, once again, we'll use a number. So this first one that I've circled is propan-1-ol. Why the heck is the number in the middle of the name? Because it tells me where this part is. The number always comes right before the group that it tells you about. So this is propan-1-ol. That tells you that the O to H is on the first carbon atom at the end. This is propan-2-ol because the OH is on the second carbon. So those numbers are telling you about location. Methanol and ethanol don't need numbers because there's only one location for the OH. Now I'm drawing it like this, and you saw in the structures they just drew the O and the H together. That's actually just kind of a simplification that gets made in more advanced organic chemistry. For us, we should probably be drawing it like this. And I haven't even really given oxygen its octet, so a full Lewis structure would look like this. So this one on the left is kind of simplified, and they do that in organic chemistry a lot because things get complicated, and so all those dots and extra bonds can kind of make things messy. But actually this thing on the right is more of a Lewis structure like you should be drawing. And then if we draw an alcohol with 2 carbons in a row, either if I stick the OH here or if I put it on the right, it doesn't really matter. Either way, it's on what I would call the first carbon. So there's only one way to draw ethanol, and these are all hydrogens. So if I draw out with all the dots and all the bonds, here's the O, here's the H, and this is what ethanol looks like. And then there's propan-1-ol, because the OH can be off the first carbon, and there's propan-2-ol. There's not propan-3-ol, because if I do that, I'm just back at propan-1-ol. Now notice I'm leaving out H's for the sake of speed in this video. Next we get to bute. Well, if we have bute and we have 4 in a row, then I can stick the OH off the first, or I can stick it off the second. So I would get butan-1-ol, and I can get butan-2-ol. And then I can't really do any others with a 4-chain, because if I do this, if I put it on what I think of as the 4th carbon, this is actually the 1st carbon again. So that's not anything new. And if I put it on the 3rd carbon, that's not really, those two are the same. 2 and 3, they're actually the same. So there is another isomer where the chain branches out, but again, that's really beyond what we're worried about. So for this video, just covering that there are 2 additional families beyond alkanes that we're going to want you to know about. One is called the alkenes, so all the names end in -ene. And if you see an -ene in a name, that means there's a carbon-to-carbon double bond. If you see an -ol in a name, that means it's an alcohol. That means there is an OH in the molecule. And the number tells you where those groups are.